In this video, I'm going to solve this second order homogeneous constant coefficient differential equation where the given equation has repeated roots. That means a root is repeated twice. The initial conditions are, by the way, y of 0 is equal to -2 and y prime of 0 is equal to 3. And this is a very straightforward problem to solve. Our assumption is that, let's say my initial solution, y of t is equal to e to the power r times t. That's an assumption I'm making. So if this is one of the solutions, then y prime of t is going to be r e to the power rt, and y double prime of t is going to be equal to r square e to the power rt. And sometimes actually we call it just y1, so one of the solutions. So let's go ahead and call it y1. Now, let's go ahead and plug in these values into this equation. So I'm going to get r square e to the power rt. So I'm just going to leave the e to the power rt because every term will have that term. So r square minus 14r plus 49, all of it multiplied by e to the power rt is equal to 0. I just straightforward did a substitution. There is nothing magical here. Obviously, this is not equal to 0 because an exponential function, right? So that kind of leaves us with these to be equal to 0. So r square minus 14r plus 49 is equal to 0, or r square minus 7r plus 49 is equal to 0. I'm just trying to factor it. So I wrote down negative 14r as 7r negative and another 7r negative. So if I factor out r, I'm going to get r minus 7. If I factor out negative 7, I'm going to get r minus 7, and that is equal to 0. So that's going to give me r minus 7 times r minus 7 is equal to 0. That tells me r is equal to 7 and 7, right? So it's a repeated root. So my solution is going to be technically y1 is equal to e to the power 7t because e to the power rt. Since the roots are repeated, the other solution is going to be of this format. So it's going to be t times e to the power 7t. So the general solution is going to be of this format. Y of t is equal to c1 times y1 plus c2 times y2. But my c1, I don't know yet. I'll find it out. y1 is e to the power 7t, e to the power 7t plus c2 times, now y2 is going to be of this format. Y2 is equal to t times e to the power 7t. So t times e to the power 7t. Why is that the case? If you'd like to know, I have made another video on this. Please watch that. So that's where I go over the theory. Now, so this is my y of t. So I kind of will be using this condition shortly, but I need to find y prime, so which is pretty straightforward. Y prime of t is going to be equal to 7c1 e to the power 7t. So I took the derivative of this, and then using the product rule, I'm going to take the derivative of that. So it's going to be c2 e to the power 7t plus c2 times 7 times t times e to the power 7t. So if y of 0 is equal to -2, so in this equation, I'll put -2 on the left, and on the right is going to be c1 plus 0, because this term is going to go to 0 because of this t. So c1 is equal to -2. Now, how do I find c2? So in this equation, I'm going to put y prime of 0 is equal to 3. So the left hand side is going to be 3 equal to 7c1. T is 0, e to the power 0 is going to be 1 plus c2 e to the power 70. E to the power 70 is going to be e to the power 0, which is 1, right? And this term, because of t, is going to vanish. Now I know c1 is negative 2, so 3 is equal to 7 times negative 2 is equal to c2, or c2 is going to be 14 plus 3 is 17. So your final solution to the differential equation is going to be y of t is equal to c1 times e to the power c1 times e to the power 70. So c1 is negative 2 times e to the power 70 plus c2 is 17. Okay, so c2 times t times e to the power 70, and that should be your final answer. So this is the solution to this given differential equation with the initial conditions, this and this. I hope that this discussion was helpful. Thank you very much.